My dear students, our today's problem is what is the value of what we mean by the divergence of the magnetic field. What is the value of del vector dot B vector? I'm starting this problem by using Gauss law. Gauss law means B vector is in SA system mu naught over 4 pi, permeability of the free space. Then this magnetic field, because of current element I dr dash vector, this is current element, okay, and I assume that it is at the origin of our system. Then cross where I am finding field at a position vector r vector, at a distance r vector from the origin, okay, then divided by r cube. Now next, taking divergence both sides, Now this may be written as del vector dot B vector is mu naught over 4 pi I del vector dot. This is dr dash vector cross r vector upon r cube. Okay. Now I'm going to apply a formula. You know a formula like del vector dot A cross B. If you don't know, please remember the result. It is B vector dot the curl of A vector minus A vector dot the curl of B vector. Now what about here? We are having here, this is A and this is B. Okay, and applying this formula. So that means del vector dot dr dash vector cross r vector upon r cube is equals to, first of all, B means r vector upon r cube dot del cross A. What is A? dr dash. Okay, then minus A. What is A? dr dash. Okay, then dot del cross B. What is B? B is r vector upon r cube. Okay. Now here, you know, del vector, this is a space vector, I cap curly by curly x plus j cap curly by curly y plus k cap curly by curly j. Mean unprime space. but this is dash, mean x dash, y dash, z dash. So moreover, I dr dash, which was the current element, it was at the origin. So del cross, there is no variation of current element with this space. There is no variation of that. So that means this cross product is 0. Okay, curl of dr dash vector is 0. Now we are having only this term now reduces to what? With minus sign and this part. Okay, so del dot B becomes equals to mu naught upon 4 pi and I, and here is a negative sign, and instead of writing this, we are writing the result. Minus sign is here, this minus sign, and then dr dash vector dot del cross r vector upon r cube. Now you can prove very easily. If you don't, then write me in the description box. Del of 1 upon r, it is minus r vector upon r cube. Okay, del vector of 1 over r is minus r vector upon r cube. If you know, then it is good. If you don't, then write me, no problem. Okay, then instead of this, I can write it here, and minus sign is also there. So we need minus sign and this part, and instead of this, writing this one. So our divergence of B becomes equals to minus mu naught over 4 pi, not minus, sorry, I, right, dr dash mu naught over 4 pi I, this one, dr dash, okay. Now then this dot is here. Now del cross, okay, del cross, then instead of writing r vector upon r cube, I am writing here del vector of 1 upon r. Curl this, cross product mean and del operator. That means curl of, this is gradient. Del vector 1 over r is gradient of some function. Curl of gradient of function is always 0. If you know, then it is good. If you don't, write me. But you can prove it very easily, no problem. Curl of, the gradient is always 0. That means what happened then? Mean dot mean then it is 0. It implies del vector dot B vector is equals to 0. Mean divergence of magnetic field is always 0. So this is the result in case of magnetostatic. Now what about, in case of electrostatic? In electrostatic, it was del of electric field is equals to 1 upon epsilon naught times the charge density. That means in magnetostatic, we are not having any magnetic charge density. Mean in magnetism, we are not having single magnetic pole. You always found a dipole, north pole and south pole. Single pole in magnetisms do not exist. So that's why in magnetisms there is no magnetic density, magnetic pole density, magnetic strength density do not exist. So that's why the divergence of P is 0. So this is the difference between electrostatic and magnetostatic, the major difference. Here in electrostatic single charge exists, means single positive charge, single negative charge exists. But in magnetism, single pole you never found. Not possible to found a single pole. If you can, then you can have a Nobel Prize. Remember. Try it. But still, there is no magnetic single pole. So that's why the divergence of P is 0. Now one thing more. You know about the electric flux? Electric flux means A dot ds. And there is a Gauss law in electrostatic that electric flux through any closed surface is 1 over epsilon naught times the charge enclosed. Now in magnetisms, the magnetic flux through any closed surface written as B dot ds, okay, using Gauss law for the magnetic flux written as B dot ds, and according to the Gauss divergence theorem, it may be written as the flux through the surface may be written as for the volume, the divergence of P for the volume in dV. Now I already proved Z dot P, divergence of P is 0. What it implies? It implies magnetic flux through any closed surface is always 0. So again, this is a difference between magnetostatic and electrostatic, remember. Now, B dot magnetic flux is equals to 0 mean? It doesn't mean there is no flux. There is magnetic flux. But the magnetic lines do not have any starting point and terminating point. They always exist in the loop, magnetic lines. If the magnetic lines, it is in the form of loop, then where you will say, where is the starting point and where is the terminating point? There is no starting point, no terminating point. Because in magnetisms, they always exist North Pole, South Pole together. You cannot isolate one pole from the other. So that's why magnetic lines are always in the loop form. There is no starting and terminating point. So that's why the flux through the closed surface, net flux, at a zero. And in case of electrostatic, there's no problem. The electric lines, there is a starting point. They started from the positive charge and they terminated on the negative charge. There is a starting point, there is a terminating point, and single pole exists. So that's why this is the Gauss law in electrostatic, and in magnetism, single pole do not exist. So, the magnetic lines, they always in the form of loop. So magnetic flux to any closed surface as always zero. This is all about today's topic. If you satisfied, then write me, and if you do not, then write me the reason. Okay? But there are many concepts for you to understand, then the matter will be clear. Thank you.